What's going on, everybody? In this video, I want to wrap up my talk about how to solve different types of inequalities with solving some rational inequalities. And so this is a similar approach to solving the polynomial inequalities in the fact that we're going to find pivot points, but the pivot points are going to be slightly different and mean slightly different things for rational inequalities based on domain restrictions as well as what the inequality sign is. So I'm going to show you guys the procedure on how to solve these types of inequalities. So in the first example for today, let's say that I had x minus 5 divided by 3 minus x is less than 0. How are we going to solve this? So luckily for us, the fraction is already simplified fully, and it's all on one side of the equation, and we have a 0 on the other side of the equation. So what we can do is go directly into testing. So what I'm going to do is I'm going to draw my number line out, and I have two places to find pivot points. And these are going to be the places where x is equal to 0, where the function is equal to 0, or where it is undefined. So what we're going to do is we're going to set the top and the bottom equal to 0 and then solve for x. And that's going to give us the pivot points that we need. So I have x minus 5 is equal to 0, and 3 minus x is equal to 0. And so when I solve the first one, I have x is equal to 5. And then the second one, I have x is equal to 3. So I'm going to mark these on the number line. And then I'm going to make these intervals distinct using different colors. Just like that. Okay? And so now the process is basically the same as it is for solving polynomial inequalities, but you have to keep in mind that x is equal to 3. We're going to have an open parentheses there because if we plug in x is 3, then we're going to get an undefined value. And we have a less than symbol, strictly less than anyway, so none of the endpoints are going to be included no matter what, so we don't really have to worry about it as much. But anyway, so I'm going to pick x is equal to 0 and see what I get. We're looking for negative values. So if I plug in 0 for x, I have 0 minus 5 divided by 3 minus 0. It's going to give me a negative 5 over 3, which is less than 0, which means that this interval checks out. So we have negative values over here, which is what we're looking for, meaning that this interval is valid. So now I'm going to pick a value in between 3 and 5 to test. So and I'm going to pick x is equal to 4. So I've got 4 minus 5 divided by 3 minus 4. That's going to give me a negative 1 over negative 1, which is a positive 1, which is definitely not less than 0. So we know that this is going to give us a positive value for any x's that we plug in there, which makes this not a valid solution interval. And then the last one I'm going to test, I'm going to say that x is equal to 6. So if 6 minus 5 divided by 3 minus 6, this gives me a 1 over minus 3, which is less than 0. So this is going to give us negative values, which is what we're looking for. So the solution set, all of the values that x can take on, are going to be contained in the two intervals marked with the red line and the blue line in the real number set. So to represent the first one, I have a negative infinity up to a 3, and this 3 is definitely not included because that's the value that makes it undefined. And I'm going to unionize it with the blue interval that I have here. And since we have a strictly less than symbol, this endpoint is not included either. And so this is the answer of all the x values that x can take on to make this inequality true. So here's the next example. I have 2 divided by x plus 1 is less than or equal to 3 divided by x minus 1. So this one's going to be a little bit more involved, and the first thing that we have to do is we have to convert this inequality into a single fraction is less than or equal to 0. So the way I'm going to do that is I'm going to subtract the fraction on the right to move it over to the same side as the fraction on the left. So I have 2 over x plus 1 minus 3 over x minus 1 is less than or equal to 0. And then what I'm going to do is I'm going to combine these two fractions together using the least common denominator and the cross multiplication. So when I do that, I have 2 times x minus 1 minus 3 times x plus 1 on the top. And on the bottom, I have x minus 1 and x plus 1 is less than or equal to 0. And then on the top, I'm going to distribute these out and then simplify. But am I thinking about foiling these on the bottom? I'm not. Because in the event that this thing combines into something that I can cancel, it's going to make the fraction a little bit easier to look at. So I have 2x minus 2 minus 3x minus 3 on the top, x minus 1, x plus 1. And then this finally simplifies into minus x minus 1. And I can factor out minus x minus 1, x minus 1, x plus 1, less than or equal to 0. And then finally, what I can make is I can factor out a negative 1 here. And I have x plus 1. So this is negative x plus 1 divided by x minus 1, x plus 1. And these cancel. So I end up with a negative 1 over x minus 1. It's less than or equal to 0. So keep in mind, I still have to use x is equal to negative 1 as a pivot point, because if I plug that value in, I'm still going to have an undefined value right there. And this is something that cannot happen. So now I'm going to solve for the pivot points. So I have x minus 1 is equal to 0, and x plus 1 is equal to 0. So my two pivot points are going to be x is equal to 1 and x is equal to negative 1. And now I'm going to draw the number line out to test them. I got a minus 1 here and a positive 1 here. I'm going to make my little color code really quick. Green in the middle, and then the last one is going to be blue. So now I'm going to pick values that are less than negative 1 to test. So I have negative 1 over negative 2 minus 1. This gives me a minus 1 over minus 3, which is a positive 1/3. But we're looking for values that are less than or equal to 0. So this doesn't work because it's positive. And so since I have positive value right here, this first interval is not going to work. So for the second one that I'm going to test, I'm going to choose x is equal to 0. So I have minus 1 over 0 minus 1. What does that give me? Negative 1 over negative 1, which gives me a positive 1, which is also greater than 0. We're looking for things that are less than or equal to 0. So since I get positive values over here too, it's going to give me no solution. And so the only interval that I have left to test is this guy right here. So I'm going to plug in positive 2 here. So I have minus 1 over 2 minus 1, which is going to give me a minus 1 over 1, which is negative 1. And this, in fact, is less than or greater than 0. So since we have a negative values for this interval, this one checks out. So our solution set is just the blue line on the number line here, which is going to be denoted by 1 to infinity. And this 1, even though we have a less than or equal to symbol, this 1 is not included, because if we plugged it in to any of the fractions, it would come up undefined. So we cannot include it anyway, regardless of the inequality sign. So I hope this video was helpful about showing you the process and how we solve rational inequalities. It's similar to how we solve polynomial inequalities. You find zeros, you find the pivot points, and then you test values that are inside the intervals created from the pivot points and see which ones fit in the inequality. That's really the big difference that we have. And the only thing is, you use the same algebra for rational equations to combine them and manipulate rational equations, but you also have to include the undefined values as your pivot points. So I hope this video was helpful. You found some value out of it. The next video, I'm going to start talking about functions. So stay tuned for the next one. Take care, everybody.